Hey everyone, welcome to this video diving into Azure App Gateway, thinking about how I can offer my web-based services out to the internet or to private networks. Before we get going, as always, if this is useful, a like, subscribe, comment and share really is appreciated, and hit that bell icon to get notified of new updates. Now in other videos, I've talked about the Azure Load Balancer. I've talked about how I select the various load balancers. And I want to focus on the idea that we have some services running that are offering something that we want our end users or end services to be able to get to. I think about, hey, I have multiple instances of some kind of resource. This could be an app service plan, it could be virtual machines, it could be something else entirely. But I have these multiple instances of my service. Now, I don't want the end consumers of this to have to know about the fact that there's multiple instances. So what we do is we create this kind of front-end IP address, which people will connect to. And then whatever service I kind of put here will distribute those incoming requests to the healthy members of what is going to be known as a backend set. These resources make up a certain set. Now, I talked about that Azure Load Balancer. Now, the Azure Load Balancer, so I could think about this, it has kind of a front-end IP, but it's what we call a layer 4 solution. So if you think about kind of the OSI layers, this understands things like TCP and UDP. But it has zero concept of things like HTTP, HTTPS, HTTP2, WebSockets. It doesn't understand that. And often, if I am offering those kind of web-based services, I want a balancing solution that understands that, because it can add additional functionality. Things like cookie-based affinity. Maybe I can offload the SSL, maybe redirection, rewrite, other capabilities. And so if this was kind of the Azure Load Balancer, well, then we have kind of App Gateway. So App Gateway is a layer 7 solution, i.e. it understands HTTP, HTTPS, HTTP2, and WebSocket. So it can kind of understand all of those various components. And so that's kind of how I can make a decision when I think about, hey, we have the Azure Load Balancer and we have Azure App Gateway, which should I use? Well, what am I offering? If it is a HTTP, HTTP2, HTTPS, WebSocket solution, well then I probably want to use App Gateway and get those additional capabilities. Now, an important point when we talk about App Gateway is often we talk about global solutions and regional solutions. So critical to understand here is App Gateway lives within a certain region. So it is not a global solution. The components that make up that Azure App Gateway live within a specific region. So maybe that's East US or West US or North Central, whatever that might be, they all exist within a single region. So if that region had a problem, well then that instance would not be available. So it's really important to actually understand that. Now when I think about actually deploying this, it deploys into your virtual network. And just a note, so obviously this is a regional solution. A global equivalent at a layer 7 would be something like Azure Front Door. So an Azure Front Door is a global solution that could then point to app gateways at the regional level. So if you needed a global, that's really Azure Front Door. Maybe Traffic Manager, but that's DNS. And again, look at my other video where I actually go through how do you pick the right load balancer solution. So when I think about deploying Azure App Gateway, I can think, well, within my particular subscription and within my region, what I actually have is a virtual network. So I have pre-created a virtual network. Remember that virtual network will have one or more IPv4 CIDR ranges, optionally IPv6. Now I'm going to create a subnet. I create it. I can call it whatever I want. I might call it App Gateway Subnet. The name doesn't actually matter. And when I actually go and deploy this, it's going to put its resources into this subnet. Now, when I think about the sizing, there were different versions of App Gateway. Now, I'm going to focus on the V2. The V1 was built on really a different set of kind of cloud services. It was the earlier version. It had different limits. It could only have, for example, 32 instances. And so when I think about the sizing of that subnet, a /26 would probably be sufficient to cover a V1. I probably want to use a /24 for the V2 because the V2 can actually have 125 instances that kind of make up App Gateway. So it needs an IP address from this subnet. So I can really think behind the scenes, it's deploying these various instances of kind of this App Gateway appliance. I don't see these, I just see App Gateway service. But in the V2, this is essentially a VM scale set. That's what it's really building behind the scenes. So as it scales, well, it's creating these, they all take an IP address from that subnet. So the subnet has to be big enough so that as it's scaling out, hey, they can get an IP address. Additionally, I can think about, well, if I opt to have a private IP, behind the scenes, again, it's kind of deploying a load balancer, and that will have a private IP, again, from that subnet, and that kind of distributes the load. Now I can, well, I will also have a public IP. So the public IP also deploys an additional external load balancer, and that's going to have kind of a public IP. Obviously, a public IP does not come from the subnet. That's a separate type of resource. So these are standard load balancers it's going to leverage. That's going to kind of distribute the traffic to the various instances it's actually creating. So from the sizing, it has to be big enough to support the maximum number I intend to scale to, and one for that kind of internal load balancer. Now, if I know, hey, I'm never going to scale beyond 4 instances, well, 4 plus 1, then I lose kind of the 5 for the subnet. I could have a much smaller subnet. But unless you're really short of IP addresses, hey, I'd probably just opt for that /24 if you can size it that way. And then as we'll kind of talk about, obviously things like web application firewall can also kind of help protect those various services that I'm actually offering. So when I do think about those IP addresses, again, we're focusing on that V2. Now the V2 has to have a public IP address. So I'm always having that public, and I can optionally have the private. So I can have public only, or I can have public and private. I cannot today just do private. I always have the public. That's because the way it's architected today, these instances have to be able to actually get outside of the VNet to talk to the various management plane components of Azure. And if I'm behind a standard load balancer, if it's private only, I wouldn't have that external access. I'd have to do like a NAT gateway or something else. So I always have to have this. Now remember, it's still sitting in a subnet. So technically, I can still use constructs like network security groups and apply that here. So although I have to have that public IP, I could, if I wanted to, restrict it so that traffic would not really go to that public IP. Now, Microsoft actually has a document that walks through that. So if I want the App Gateway V2, again, the V1 can just have a private IP. But if I only want that private front end, it basically talks about, look, you have to have the public IP, either public IP only or private and public IP. But if you just want the private IP to be usable, hey, you can go through using the network security groups and essentially lock it down so that public IP really just wouldn't be addressable. And what I'm going to do is I'm going to probably talk about a lot of links during this video. They're all in the description. So go and look at the description. I'll have the links for all of these various things. So yes, it always has a public IP when I think about the v2, but if I really wanted to, yes, I can essentially hide it away. Now, we do have this idea, again, of the web application firewall as well. I'm drawing it on the outside. It doesn't live on the outside. It's kind of enabled through the various components. But there's a WAF v1 and a WAF v2 that kind of correlates to the v1 and the v2 version of Azure App Gateway. Now, as I mentioned, I'm going to focus on the v2 version of the SKUs. Now, there's not actually a huge amount of difference in the components. It's really just some things about some of the additional functionality we get with the v2. But I guess just super quickly so we understand those things. And there is some variance in how these things are priced. So if I think kind of dollars, with the v1 SKU, the way the v1 worked is we had different types of app gateway. So I could think there was kind of a SKU where we had a size. So we had like small, medium, large, there were tiers. And how many instances did I actually have? So we had those elements. And then I also paid for the amount of data processed. The v2 has kind of shifted. So on the v2, doesn't actually care about the number of instances. What we pay for is, hey, do we have App Gateway configured? And do we have, optionally, the web application firewall configured? And that's basically an hourly cost. So whether there's 10 instances or one, it's just an App Gateway cost. And then we pay for these things called capacity units. So this is how we handle things, hey, based on the scaling, they're 2, they're 5, they're 10, because the capacity units handle things like, well, how many persistent connections do we have? They handle things like, well, what is actually the throughput? And then they actually handle compute units, the kind of work being done. So it's kind of this fixed cost and then these variable costs. So it does vary between the v1 and the v2, what they actually are. And again, we can go and look at the documentation. And there's a whole document about the pricing. And then it talks about the v1 SKUs. Hey, yeah, look, v1, there's the fixed cost, the tier, the size, number of instances. And then the variable is the amount of data processed. So that's how you work out the v1 SKUs. For the v2 SKU, there's all examples, you can really understand all of this. That variable part, well, is this capacity unit. And that capacity unit really is, hey, each capacity unit has these 2,500 persistent connections, a certain amount of throughput, and you get a compute unit with it. And then that compute unit itself, hey, here's the guidance, here's the number of connections it can handle, how many capacity units we get, etc., etc. And then you just have this fixed amount of time the app gateway is provisioned for, or the WAF. It doesn't matter how many instances, if it's provisioned, I pay for those things. And again, there's kind of examples that go through all of those various things. Now, sometimes you'll actually see kind of the standard v1 just called basic. So when we talk about standard v1, you may see the term basic, but the v2 we always refer to as kind of standard v2, and then WAF v2 if we add that optional WAF actually to it. One of the things the v2 adds is actually some additional functionality. And realize, because it is a layer 7, we get certain features anyway. So we talked for a second about this idea of, hey, layer 7. So because we are layer 7, we get a bunch of features. So I can do things like URL redirection, and also I can do URL-based routing, or routing, if I use the English terminology. I can also do things where I understand the URL. I can do things like rewrite. I can actually change elements of the URL. I also can change elements of not just the URL, but also things like the request. I can modify many different things about that. Because I'm at the layer 7, I can do things like SSL, TLS, termination, and offload. So what that basically means is, ordinarily when I have kind of a TLS connection, I can think, hey, the client comes in and it's talking to some back-end resource. That establishment of the TLS and the compute associated is to the back-end resource. So this resource has to do a whole bunch of computation and work around, okay, that decryption and encryption. Well, when we put in App Gateway, now, so before that was kind of the TLS going here and that way, now I can actually just do it to here. It can offload the work, and then it can just send regular HTTP, i.e. unencrypted, removing the work from that back-end resource, but I still have that kind of encryption to protect me. Now, I can do end-to-end still if I want to, but I don't have to. We can do things like session-based affinity. Again, now we understand layer 7, I can do things like cookies. Because I'm layer 7, I can do things like connection draining. So we gain a whole bunch of functionality because I actually have these things. Now, with the V2, one of the nice things we actually got, is kind of here. Well, the V2 gives us things like auto scale. So it can change the number of instances we actually have here based on the work coming in. If I actually go and look for a second, if we jump over and I go and look at my app gateway, I can see on the configuration, hey look, I can do a manual scaling, and I've set it to 1 because I'm cheap, or I can say auto scale. And notice here we can go all the way up to 125. So it will auto scale based actually on the amount of work. I could set the minimum maybe to 3, for example. Or I can go back to the manual. Also notice on this page while we are here, this is where I can enable or disable HTTP 2. So just kind of bear that in mind. So with the V2, we get that nice auto scale. Now, if I was just go and create a new app gateway, one of the other nice things that the V2 does is notice we have this option about availability zones. So let's pick a different zone that actually has it. So notice I could pin it to a certain zone, or I could just say, hey, I'll have it in 3 zones. I'm actually resilient across zones, or I could make it zonal and just pin it to 1. So one of the great things we also get with this nice V2 is I get AZ support. Now I don't get that with the V1. If we went back for a second and looked, and actually note a few other things. So this is the V2 SKU, and notice we have this availability zone. If I change it to the just the standard, that AZ option has gone away. But notice now I also get this SKU size, small, medium, large. That does not exist for the V2. We just have kind of those auto scale. There's no concept of this SKU size thing, because in the V1 we pay differently based on these. So when I go to the standard V2, there's no idea about size. We just have these kind of scale capabilities. And once again, I can enable or disable the HTTP2. And notice you're going to configure that virtual network when I actually go and create it. But I've already got mine. Some other, I guess, big changes from the V1 is it's always static IPs. So it's always going to be static. They added things like header rewrite. So a kind of header rewrite. It's all static. Kind of those virtual IPs, and it's actually a nice document. So if we jump over, and again it's going to be in the links in the description, You can see the comparisons between V1 and V2. And hey, I can see that, okay, the V2 SKU, auto scaling, zone redundancy, static VIP, AKS ingress controller, integrates with Key Vault for the certificates that we can actually use, and rewrite HTTP, HTTPS headers. There's also web application firewall custom rules. You can see that one there as well for the V2. And then that's it. So those are the key differences between the V1 and that V kind of 2. So we have those things available to us. So we have these nice features, all of this goodness, again, things like cookie-based affinity we have there. The connection draining is really nice because now I can have like a backend set member, maybe I want to replace or update. I can let current connections kind of finish over a timeout that I configure, and then I can actually remove it and kind of be on my merry way. Okay, so they're the features. How does it actually work? So I kind of started to allude to the fact that, well, hey, look, there's back-end resources, and then there's some front end. I talked about there's these app gateways. So they're the physical components. There's a whole bunch of logical components that I configure to actually make this thing work. So let's kind of take a step back. So I'm sending traffic to something. There were those back-end set members, either things actually hosting this web service that I want to enable connectivity to. And it really supports a lot of different things when I think about App Gateway. It's very different from like the Azure Load Balancer where, hey, I need things in my VNet, either NICs or IP addresses. So when I think about those back-end sets, so we're going to create a back-end set. Called back-end set 1. In that back-end set, I could point to app services, like an Azure app service. I could point to a virtual machine. I could point to a virtual machine scale set. So those are things in Azure. But I could also point to an IP address, to a fully qualified domain name. Now for these app services, these VMs, the VM scale sets, they can actually be in any region. It doesn't care. So I could point to things, I might have a VNet in another region. Remember, virtual networks are regional, but I could go and peer to a VNet in another region so I can get to that thing. But remember, the key point here, App Gateway itself exists in a certain region. So yes, I can point to things in different regions, but if the region the App Gateway is in, it's not pointing to anything anymore. So this is not a global balancing solution because I have that single region kind of point of failure. So I don't consider this a global solution. Yes, it can point to things anywhere, but it as a unit of work, a feature, exists in a single region. These IP addresses, well, these could be on premises. Again, I just need a network connection to them from the virtual network to App Gateway. So for example, I might have my on-prem network and maybe I'm connecting via site-to-site VPN. Maybe I have ExpressRoute. So I could include an IP address or resolvable fully qualified domain name that's on premises. It could be something out public. So it could be a public IP out on the internet. It doesn't matter. So public IP name. It just has to be able to get to it. So my key point about all of this, when I think about Azure App Gateway, I just need IP connectivity. If I can get to it from an IP perspective, it can be part of the backend set. That's it. Everything else is just kind of, I'm going into bits of detail that really aren't that important. If I can get to it from IP, it could be part of the backend set. And obviously, I'm probably going to have multiple backend sets. So I might have another backend set 2. I might have a backend set 3 with different sets of resources in it, or some of them might be the same resources in it. Now in the portal, when I go and like browse for app services, VMs, VM scale sets, it will only show me things in my current subscription, but that's just a portal. I can absolutely, through other means, add resources from other subscriptions. It doesn't care. So that's great. So from the backend set members, what can be in it? I can really have anything I want. That's super easy. So that's one end of the picture, the stuff I'm actually going to go and get to. Now obviously there's other stuff before that. And again, we talked about this. So we talked about the idea of these IP addresses. Always have a public IP, and optionally I can have a private IP. So I think about, I have these static IP addresses. So I can go, okay, I hope I'm going to scale this picture right. But we'll say we have this static IP. So remember, we always have a public. We can optionally have a private. Don't have to have that, we can do. There's also always a DNS name that doesn't change for the life of the app gateway, that will kind of point to the IP address. Again, in V2, these are static. In V1, they could be dynamic. That's why we kind of have that. And optionally, now I'm drawing this logically, we can have that web application firewall. I'm not going into detail about that in this, but because this actually kind of exists within the components, but it just complicates the picture. But that does those additional types of checks. So it has those core rule sets, protects from things like SQL injection attacks, and much, much more. For the V2, I can actually customize those WAF rules as well. There's a bunch of extra stuff I can actually do there. So we have the idea of this IP address. Now, with an IP address, hey, I can have different ports coming in. I have different protocols I support. To actually get to it, it may have used different DNS names, like the fully qualified domain name. I don't go to an IP address. I go to www.saviltech.com. And then from DNS, that resolves to an IP address, and maybe port 80 if it's just regular HTTP, or port 443 if it's HTTPS. So the next component we have is something that has to kind of, well, listen for traffic. So they originally named it, and it makes it fairly obvious what it does. There is a listener. And so the listener is taking certain traffic from the IP address. So it's tracking a certain IP, a certain port, and a certain protocol. And optionally, it can think about the host name. I'm going to talk more about that. Because we do get sent kind of the host name as well. And there's different mechanisms of doing that. The host header will have the host name. If it's encrypted, there's actually server name indication, SNI, that will still, even if we don't know what's in the packet, we can still know, well, this is the address it was actually sent to. So we think about, okay, I'm going to have a listener, and it's kind of listening on a certain IP address. Now, that IP address will have multiple different listeners connecting to it. So I can think about there's n number of listeners, but a listener is tied to a particular IP address. So this one IP will have multiple listeners across different ports and protocols actually listening to it. Now, there are different types of listener, depending on what I'm actually trying to do. There's something called the basic listener. So if I have a basic listener, it is just essentially all traffic for that IP port protocol. It's just sending everything. It does not care. Then there's also, I'm going to run out of space, aren't I? I'm going to change the color to make this a bit obvious. No, I'll keep it green. There you go. There's also the idea of multi-site. Now, the goal of the multi-site is, you can imagine, I only have one public IP and one private IP. But what if I wanted to be able to have multiple different websites hosted on the same app gateway? But actually what is coming in is it uses different host names. www.savotech.com, www.contoso.com, www.savtech.net. But they're all coming into the same public IP. So with multi-site, what it lets us do is have different listeners using the same IP, port, and protocol. So it's going to have these additional kind of checks to say, well, which listener does this match? And it will be based on that host name. So we have the same kind of IP, port, protocol. But what we can then actually do is use that fully qualified domain name. So using that fully qualified domain name, and again, that could be from the host header. That could be using server name indication, SNI. There were things like wildcards and question marks for single characters supported as part of that. And then that helps us work out, well, which actual listener should this one apply to? Because I've got multiple listeners on the same IP port protocol. Well, it's going to go and look at, well, what's the host header? What does SNI tell us about the actual name that the client requested? So, hey, I'm over here, and I go to www.savotech.com. When the host header, it can see, oh, even if this was encrypted with HTTPS, well, I can use SNI there. Okay, well, this listener listens to star.savotech.com. If I went to savtech.net, there's another listener that says star.savtech.net. So that would be a different listener. So I can think about, hey, I can have multiple listeners. Normally it's different ports and protocols, but I can have multi-site rules, and then each of those multi-site rules, yes, it says the same IP port protocol, but it's going to use a different fully qualified domain name to be able to separate, hey, what is that request actually doing? So this is probably easier to kind of just see this. So if we jump over for a second, so let's close that. So if I jump over for my app gateway, you can see I already added a listener. And if I look at my listener, we can see I'm listening on, I have public or private IP. I specify the port. And this was a basic listener type, not a multi-site. And then I associate a rule. Ignore that for now. So what that means, if I try to add another listener, and I did the same front-end IP, it will not let me do port 80 because I already used that on one of the other rules. I can't do that. Now I could say 8080, and that's a unique port. It's fine. I can use other ports for that. I could also say, oh, well, this is HTTPS, and it's, again, there's nothing on HTTPS right now, so it's defaulting to 443. I'm going to go back to the 8080. Now, notice I can do multi-site. Now, with a multi-site, I can either have an absolute name. So I could say www.savotech.com. I can't use wildcards. I just have to do the fully qualified domain name. I can have one of those, and that is this rule. Or I can say, actually, I want to either support wildcards or have multiple ones. So if I say multiple, well, now I can do things like star.savotech.com. Or maybe also on this one, I'll do, it could be like 3 characters. Maybe it's savotech.co.uk. So I can add up to 5 of these for this multi-site. And then I could go and add this. So this is me actually going and creating this listener. So that was 8080 HTTP. So I could click add. Now, I could add, let's say test 2, the same front-end IP, port 8080, but it's going to let me because I can do multi-site. And now I could do a different list of host names. Now maybe this is now www. Or actually I'll just do star.saviltech.net. I'll just do one, but I wanted to use a wildcard. Add. My names are terrible, it's going to confuse me later on, but you get the idea. I can actually go and add those. So that's the whole point of doing these things. It lets me, with that multi-site, as exactly as the name suggests, hey, I can use the same port and protocols across different rules, so different listeners. And that ultimately is what's going to let me send to different backend sets from that same shared public IP and or private IP. So that's where I use multi-site. Hey, I want to be able to have multiple listeners. I'm just going to vary based on the fully qualified domain name, because ultimately I'm going to then make different routing decisions on where it goes on the back end. Exactly my scenario. I have one set of backend servers for saviltech.com, maybe another set for saviltech.net, completely different sites, but I only have the one public IP. But hey, I can go and look at that host header or SNI, and then later on I can do different things because they're going to go to different listeners based on that multi-site. Now you'll notice I don't configure WebSockets anywhere here. WebSockets is just enabled by default, and it will work over both HTTP and HTTPS. HTTP2, remember, was part of that configuration. When I actually create it, I can say turn on HTTP2, and in the configuration, I can turn that on or off as well. I showed you that earlier on. So this is just me picking the listener. So that is fundamentally just, hey, I'm listening on that thing. Now, one of the things if I did HTTPS is obviously I have to have a certificate. So also I do kind of configure, if I'm doing HTTPS, the certificate that then the basic or kind of the multi-site rule would point to. And I can upload that file. So if we go back over for a second, if I was going to add that listener again, if I do HTTPS, you notice, hey, I can upload the cert that it's actually going to use. So this would kind of be the private key, or this is this integration with Key Vault. I can actually choose it from Key Vault. So that's one of those nice new V2 features. So this will enable it to do that TLS kind of offload and let it do the work and save that on my back end side. So I can absolutely do that. Okay, next. So all we've done right now is have a listener that will take certain traffic based on these conditions. Well, now what I ultimately want to do, remember, is get that traffic to a backend set. So what we then have is a rule. And I basically link the rule to a certain listener. This is kind of a one-to-one relationship. So a listener is associated with one rule, and a rule links to one listener. And it's the rule that actually then governs, well, what backend set am I actually going to do? Now, there are different types of rule. There's something called basic. And as the basic kind of says, hey, just everything just go there. My other option is I have kind of a path-based. So it's going to look at the path of the request. So again, when I go www.saviltech.com, well, actually, as part of that, I might say /blog, or maybe there's /cart or something else. So that's the path. So I can use the path actually as part of the routing decision. So again, I have different backend sets handling different parts of my website. So I can say, hey, if it goes to blog, we'll then send it to this backend set. If it's going to cart, we'll then send it to that backend set. So I have those different types of rule, but it's still one rule. It's just within the rule, it will have the different paths I can identify, and I link the different backend sets. Now there's a little bit of magic going on, because remember, for the path base, we have to be able to see the path. Remember, we're doing the SSL offload here, and I'll come back to that, and I'll talk about how we're actually doing that. But it can see the path because it's doing that SSL TLS termination so I can see the full URL. I'm not just seeing the fully qualified domain name from SNI, for example. So I can actually see the path. So let's look at one of these. So again, we'll jump over. So now we go to rules. And you already kind of saw, notice my listener had an associated rule. So if I go to my rule and select the rule, you notice it's tied to the listener. So I select it. I can't link it to another listener. It's very much a one-to-one relationship with that. And then also within the rule, you specify the backend set. So I can do a backend pull or ignore the redirection for now. I'll talk about that in a second. So the rule really is just saying, hey, for this listener, here's your backend target. And my backend pulls, here's the one I created. I just add stuff, but I can add VMs, VM scale sets, app services, or IP address fully qualified domain name. Again, it does not care. If you can get to it from a networking perspective, that's all that matters. If I create a new rule, so I'll call it rule 2, we have to associate it with a listener that's not currently used. So remember, it's not showing my main listener because it already has a rule. But I can select one of my new listeners I just created. And then I could go and select my backend targets. Now by default, remember, it's just wanting my backend target, what pull, remember I can reuse the pulls, and then my HTTP settings. I'm going to talk about that in a second. But they give me things like, do I want to do re-encryption, the type of affinity, draining, probing, those types of things. Or I can do path-based rules. So here, I could say, hey, what's the path? So my path is blog. My target name, blog target. Then it has its own set of configurations. So I can really think about the flow is based on the unique kind of rules to the backend sets. So when I drew this picture, and we're going to start adding to this, each of these entries has its own selection of kind of the HTTP settings I actually want to leverage. So again, we can see, hey, what is the target I want to get to? And what are its HTTP settings? And then I could go and add multiple ones of these to target hey / cart, etc., etc. So we'll cancel out of that for now. And I've obviously realized I just did my slash the wrong way around, so we're trying to make this as professional as possible. I'll at least get my slashes the right way around, just try not to be completely incompetent. So that's all that does. But you can see, hey, within one rule, I can have different paths going to different places. So then we saw a couple of different options I could actually do there. Now, one thing I should say, when I have these multiple possible targets as part of that backend set, well, what it is doing is round robin. It's just anything that's healthy, it's going to round robin the request if there's multiple possible backends in that backend set. Now, the other thing we can actually do is, well, we can have a redirection rule. So we saw that actually in the options there. So the other thing I could actually do is redirection. So with redirection, I can redirect to a different listener. So that I would think about, hey, it came in as HTTP. I want to redirect it to HTTPS. I want to make it kind of encrypted. Or I just want to do some external site, just redirect it somewhere else completely when it comes in. So I don't want to send it to a backend set. I want to either redirect it to a different listener, my 443 encrypted, or just redirect it somewhere else completely random. So again, we go back to our rules. If I do a new request routing rule, doesn't really matter what the name is, pick a different listener. Notice I can do redirection. Now, is it a different listener? So I could redirect it probably to a HTTPS listener, or I just put in an external site. Hey, I'm going to go and redirect to contoso.com. And I can say, do I want to include the query, include the path? And I'm doing this for the entire rule, i.e. this is just a basic. I could do the same thing with multiple targets. Once again, I could say, hey, maybe my shopping cart, well, do you know what? That's actually, I want to make sure that's encrypted. So I'm going to maybe redirect HTTPS, so I could go and redirect that to a different backend, redirection. I want to redirect that to a different listener, my HTTPS listener. Or maybe I have just a completely different site to actually host that, so I'll redirect it to an external site. So I have those options both for everything, or again, based on the path, I can do different things. So that's the same one. There we go. So I could add that. So you can now see there's a path. And I could go and add another path. So now maybe I'll do blog. And that one doesn't have to be redirection. Maybe that just is a backend pull. So that could be my blog pull. So I can mix them up when I'm doing that path-based. This one, hey, no, that's good. I'll just send it to my VMs, add. So now we can see, hey, I've got path-based and redirection within the same rule. And I can just keep adding these as I want to. So that's the basic rules. So that gives me the redirection and all of those different capabilities that I have there. Now the other thing I might want to do is maybe I want to change stuff. So maybe stuff came in that isn't actually how I want it. So the next thing I can actually do is a rewrite rule. And the relationship here is, hey, a rule can be associated with multiple rewrite rules, and a rewrite rule can be associated with multiple rules. I can reuse them all over the place. So I can rewrite things like the header. I can rewrite things like the URL. Because I'm messing around in here, I can do things like cookie, query string. I can pretty much change anything. Parameters, I could change if I wanted to. Essentially, go and rewrite what's come in before it then actually can go to the path rules. So I might rewrite things in the URL, which would then influence, well, what path-based rule would it then actually, what backend set would it actually go to? So if we jump over, if I go to my rewrites, I create a new rewrite set. I give it some name, rewrite 1. We associate it with n number of rules. If I had other rules, I could associate it with them. And then my configuration. And this is kind of a nice GUI experience. So I add a rewrite rule, and it says do this. And then this could actually be, well, I can rewrite the request header, or the response header, or the URL. So I have different options here. And you see for the request header, hey, I can set or delete elements of that. Is it the common header? So there'd be different elements we typically see in the header, or it could be custom. Now, I type it in and I put my new value. If it was the URL, for example, well then I can't delete, but I can set, or I can change the URL path, the query string, or both the URL path and the query string. So we'll change the path, and then, hey, what's the bit I'm actually changing? And then reevaluate the path map. Because I've changed it, I now want the rules to go and reevaluate it. And notice we can actually put these in order. And what I can do is I can add multiple ones to this. So I could set that one, then I could add a new action to do something else, and then I could add conditions. I have all these different things I can actually do within here. So I create this set of rewrites. I have the sequence for all of these different items and what I'm doing. I can delete the various things as part of this. Notice I can go and do if. Hey, if the HTTP header or some variable case sensitive checks, operators, then go and do something else. So I have these really powerful capabilities to actually rewrite these things. So I'm leveraging that and linking those. Let's cancel out that. So I'm linking that from the rule. Now the next part we saw as part of the rule was, what color haven't I used yet? Okay, people get excited when I pull out the gold. All right, so we'll do gold. So the next thing I can actually have is kind of the HTTP settings. So once again, it's the rule that links to the HTTP settings. So a rule can only link to one HTTP settings, but HTTP settings can be used by multiple rules. I use capital N sometimes and uppercase in other times. Now the HTTP settings is all about, hey, I want to do things like I want to re-encrypt. So remember I talked before about the idea that, I don't know where I drew that picture. Somewhere on this board I drew a picture of something decrypting. Let's zoom out for a second. There, okay. I drew this idea of, hey, the app gateway actually does the decryption, then could send it just regular HTTP to the back end. What about if I didn't want to? What about if I want this to be encrypted? Well, it's in the HTTP settings, I can actually say, hey, I want to send that re-encrypted. So over here I can configure, hey, I want to do the re-encryption. I can here set things like cookie affinity, i.e. stickiness to certain backends based on a cookie. I can enable things like draining and what is the time limit to do the draining to finish off current sessions. I can do things like have custom probing to check the health of these. So these are really super important. And again, this could then actually connect to health probes. If I had a custom health probe configuration, and again, HTTP settings will only use one, but a health probe could be used by n number of HTTP settings. This custom is completely optional, or it has kind of this built-in capability as well. So once again, if we jump over, if I go and look at my HTTP settings, you can see I have one very basic port 80 HTTP protocol. I've enabled cookie-based affinity. I could enable connection draining. If I do, what's the drain timeout it has to finish existing sessions? So it wouldn't allow new ones to connect, but it will give 60 seconds to these other ones, and then it will kind of remove it from the environment. Request timeouts, override backend paths, host name modifications over here, host name overrides. Do I want to use a custom probe? If I say yes, then I would have to go and add what the custom probe is. I haven't configured any of them. But that's just the basic kind of HTTP. Now, if I do HTTPS, I have to add the trusted root certificate for the chain, unless it's using a well-known CA certificate. So what is this talking about? So if you think about on this backend set, if it was offering something on HTTPS, i.e. I want to, remember, re-encrypt the traffic. So if I'm doing HTTPS, the way that fundamentally works is I have a certificate. So I have kind of my private key here, then there's a public key that I know that I can use to do that initial communication and then find a symmetric key we can use for the actual stuff. Well, that private key and this whole certificate was issued by something. And so whatever that issuer was, there's kind of a root certificate authority that normally then signs some intermediary CA that actually then goes and creates my web cert. So this might be some internal root CA that Azure App Gateway would not trust, so it will fail. So I have to take the public key of the root, oh, I completely misspelled public, there's no R in public. I have to take the public key of my root CA certificate and bring that in to my HTTP settings. So that's what it's asking for. Now, if this web cert I'm using on my servers was issued by one of the internet standards like a VeriSign or DigiCert or something like that, well then that's already built into the trusted root CAs, i.e. I don't have to do that import. So that's what that screen is basically saying. It's saying, look, I need the root CA certificate. So upload the public certificate of the backend servers to this HTTP setting, unless I'm using a well-known, in which case, if I'm saying, yes, it's well-known, I don't have to import the certificate anymore. It's good. It's going to trust it anyway. There's nothing more I need to do. So with this setting, now if I'm setting this backend protocol to HTTPS, this is what is telling it to re-encrypt the traffic. If I just say HTTP, it's going to send it unencrypted. Remember, at that front end on the listener, it will have done the decryption. So if it was HTTPS coming in, remember it offloads. This is where it decrypted it at the listener. So now it's just regular, basically HTTP. But if I'm saying, no, when it gets sent here, I want it encrypted, well then I set the HTTP settings to HTTPS, and I have to give it that root public key so it knows to trust it, so it will use that for that actual initial establishment and then the sending of the data over. Or if this was issued by a well-known, I don't need to do anything because it's already going to be built into those kind of virtual appliances as part of that OS. It's already trusted. It will allow it to be used for that TLS establishment. So that's kind of the key point of that. So that's what the HTTPS settings are used for. And again, you saw kind of that cookie affinity, the draining, the probing. I had all of those kind of other options within there. So that's kind of put all of this together at this point. With that, all of these things now talk. Hey, traffic comes in. Optionally WAF. The WAF really kind of sits there, but I kind of draw it on the outside. Okay, it goes to a listener that matches the IP port protocol if it's multi-site based on the host name. Okay, the rules then tell it where to go, or I can use the path as well if it's a path based, or I might redirect it to a different listener. Hey, I want to go HTTP to HTTPS. I can rewrite bits of it, and if I rewrite, I can say reevaluate the rules because it's been rewritten. Maybe it now goes different rule. HTTP settings enabling me to do, hey, yes, you did the offload and decrypted it. I want to re-encrypt it. Okay, well, I need to make sure I've got the cert if it's not from a well-known kind of public issuer. Cookie affinity, draining. If I want custom probes, then it goes to the back-end sets, which again, if I have IP connectivity, it's just going to work. And that's it. I mean, that's App Gateway. The only other thing I'll quickly mention, because more and more people are kind of using Kubernetes and AKS, one of the kind of special features of App Gateway is it can act as an ingress controller for App Gateway. Sorry, for Azure Kubernetes services. It's been a long morning already. Now, if you think about it, the whole point of containers is I have some AKS cluster. Now, there's really a data plane where the workers live and the kind of managed control plane, but forget about that for now. I just have pods. Remember, I just have those pods that are running inside the pod. I have an instance of my containers, little sidecar with the networking stack, but I have pods. And what I want to be able to do is use App Gateway. I think that's the icon for App Gateway. I want the traffic to come into here and then it distribute it to the pods. Now remember, one of the tricky things we have here is the whole point of these pods is I might have kind of replica sets. So the number of them maybe vary based on scale conditions. So pods are being added and removed. Well, I need to make sure the rules are updated to make sure it's pointing to all the valid pods or remove pods that aren't valid anymore. So the way this works is what App Gateway does is App Gateway actually adds a pod. So what we have added here is the kind of App Gateway ingress controller. And there's the Kubernetes API, the API scheduler. So what the App Gateway ingress controller does is it's kind of monitoring it. It's listening for things that change. So hey, a pod's been added. And the pod's been added to a deployment that I'm providing the service to distribute the traffic to. So when it sees a change, it goes and configures via ARM, the Azure Resource Manager. It reconfigures this to now distribute to the right pods. And then as the traffic comes in, hey, it distributes to the pods directly. Now, there are different networking configurations for Azure Kubernetes Service. If I'm using CNI, with CNI, the pods have valid IP on the network. So it can just talk to it directly. There's nothing more I need to do. If I'm using KubeNet, then the pods have an isolated IP space that is not valid on the network. Essentially, all the traffic is natted out. So what we have to do is this AKS actually lives within a subnet, all the worker nodes. And that subnet actually has a route table associated with it. And so that route table, when I have KubeNet, specifies, hey, this portion of the isolated IP space lives on this worker node. This is on this worker node. So what I would actually have to do is that route table, if I'm using KubeNet, I have to associate to the app gateway subnet as well. So I would essentially, that route table, I would associate. So now the app gateway knows which host to send it to for that target pod. So just realize, so it still kind of works a similar fashion, but I need to have that route table associated so it knows how to send it there, because the IP address when I'm using KubeNet is from a different IP space that's not part of the virtual network that the AKS on its own would have zero clue how to get to. So I have to basically take this route table that's automatically maintained actually by, I've got to change the color of that to make it match, that's maintained as part of the KubeNet networking. Well, I'm going to associate that route table with my app gateway subnet. So now it also knows, hey, pod 1, hey, you're on this node. Pod 2, you're on this node. So I can still know to send it to the node, which will then get it to the various pod. So there's a whole bunch of NAT essentially goes on when I'm using KubeNet. So that's how it works as an ingress controller. I have a whole video on AKS networking deep dive if that's something you're interested in. I want to kind of throw that out there because that is kind of an important point. That's a big piece of functionality. But that's it. I really hope that was useful. I hope it clears away some of the mystery of App Gateway. It's really not complicated, and it's really nice sets of functionality, very powerful using these kind of, especially like multi-site, these path-based rules, the redirection I can do, rewrites, different settings. Yeah. So again, a lot of work goes into these videos. I really would appreciate a like and subscribe. But until next time, take care.